Now, homologous series. Homologous series. Welcome back to another wonderful class. Homologous series. Now, what is the meaning of homologous series? Homologous series is a series of organic compounds whose successive members differ by a methylene or a CH2 group or a mass number 14 grams per mole. A series of organic compounds whose successive members differs by a CH2. Look at it. Where I wrote it. If you just write anyhow CH2, it's not correct to. The CH2 you have a bond here and a bond here. That is how. If you check inside this actual series, you see that all of them are differed by CH2 that has a bond here and a bond there. This is the most correct way to write this. You're not just going to write CH2 like that. Carbon should have 4 bonds. We have already explained that. So, a homologous series is a series of organic compounds whose successive members differ by CH2 or a mass number 14 grams per mole. So, we quickly be looking at the homologous series of alkenes, and alkynes. Then I already told you alkynes can be gotten from alkenes if you remove just one. If you remove one from these two, now you're going to have one there. Both of them are the same. We have already explained this molecular formula of each of them. So, let me just show you how to use them now. Let me just show you how to use them. For example, now for alkanes, I already told you start from 1, but alkenes and alkynes start from what? 2. Alkynes is just like alkane, but you just remove one nitrogen. That's all. Then next, if n is 1, we have CH4. You put 1 here, put 1 here. You have C1, although you don't put the 1 if it's 1. You don't write the C. Then you put 1 here, 2 times 1, that is 2 plus 1, you have 4. Then if n is 2, you have C2. Then you put 2 here, 2 times 2, 4, plus 2, 6. That's how to get it. If n is 3, put 3 here, C3. 2 times 3 is 6, plus 2, 8. That's how to get that. So, what's the name of when n is 1? For alkane series, we have methane when n is 1. We have ethane when n is 2. We have propane when n is 3, and so on. I will be showing you guys how to do this from number 1 to 100. So please don't distract yourself by any means. Don't skip any part of this video. Just watch us as we'll be doing this. I'm very sure you will gain a lot from this. So just watch us as we be doing this. So just watch us. We are together. We are together. So let's look at this. Let me quickly explain alkane, alkenes, and alkyne. Now, what's the meaning of alkane? I already told you alkane are saturated hydrocarbons. They are saturated hydrocarbons that are comprised of a straight-up branching carbon-carbon single bonds. Carbon-carbon single bond. So the trivial name of the alkanes, the trivial names of these alkanes is called the paraffins. We call them the paraffins. That's what we call it, the paraffins. That is their trivial or guy names. But there is another thing very, very important. The simplest member of this alkane, is the methane molecule. That's the simplest member of this alkane. And again, alkanes they ranges from maybe gases to liquid, then to was solid. If the numbers of carbon increases, there are something like a boiling point or melting point will also increase. For example, now if you are moving from maybe like 1 carbon atom, let's say C3, 3 carbon atom to 10, the thing will be moving from gases to liquid and to was, to get to was solid. That's what it is. So if you have maybe like you say you have C1, C2, C3, C4, C5, C6, C7, you say which of them could be necessary liquid? Should be the one that have the highest carbon atom. The higher the carbon atom, the higher you get closer to that, the higher their boiling points, melting points, and the rest. So that's how it is. That is the form of their chemical, physical properties. Then methane is having just 4, something like, it has just 1 carbon atom. It has 4 sigma bond and no pi bond. There's no pi bond because alkanes don't have pi bond. Alkanes don't have pi bond because they are all single carbon. They are all single bond throughout. Then look at it. We are still going. We are still going. Most alkanes, hydrocarbons alkanes, don't have pi bonds. That is from this homologous series, getting from this formula. They don't have pi bond. Then we are still going. We are still going. Then now methane. Hmm? Methane is a kind of compound that have a something like a tetrahedral shape because it is having a hybridization. I already something like delivered a class on that hybridization, like primary class anyway, and I explained that for a methane, ethene, and ethine. Now methane is sp3 hybridized. Because of that, it's tetrahedral shape, and the bond angle is 109.5. 109 what? Dot 5. I'm explaining methane now. I'm explaining methane. So most things that are having single bond and four bond attached to them are always mostly sp3 hybridized. Sp3 what? Hybridized. Now, one of the chemical property of this alkane is that they are very good in substitution reaction. In what? Substitution reaction. But they are not good in addition reaction. Take note of that. Especially when you want to add hydrogen or hydrogen halide to them. But oxidation, maybe they can oxidize, yes. Can be able to they can oxidize. But one of their characteristics is that one of the difference between one way to differentiate this saturated and unsaturated compound is that substitution and addition reaction. These saturated compounds are not good in addition reaction. We have what we call addition reaction. We have what we call substitution reaction. Substitution is when you have a compound, an atom will come and replace another atom. There, for example, now let's say we have methane to react with chlorine. Before you know it, one chlorine atom first of all come replace one hydrogen. We have chloroethane, chloromethane, chloro dichloro methane, tetrachloromethane, and so on, to get to the case in which all the hydrogen will be replaced by this chlorine. So chlorine can replace hydrogen here, substitute something like just displace hydrogen here. That's what we call substitution reaction. Sometimes another compound just come replace the hydrogen atom that is here. Then one of the hydrogen, then the other hydrogen will come and clip with the other chlorine to form hydrochloric acid. So that is the substitution reaction they do undergoes. So you can look at that substitution reaction. It's very, very important for all those alkanes. But alkanes are unsaturated. The version is saturated because it has carbon single bond throughout. The version is unsaturated because you have multiple bond, which is carbon double bond. Alkanes are unsaturated with carbons that have a trival name called the olefin. That is their trival name, the olefins. The olefins. Now, the simplest member of this alkane is the ethene molecule. Ethene molecule. I already showed you ethene, which is C2H4. Have two carbons. It's C2H4. Now C2H, that's ethene molecule, is something like a sp2 hybridized. Is sp2 hybridized, and it has a bond angle of 120 degree. 120 degree. Now we have sp2, sp3, and sp. It is inside this channel. You can look at them. Hybridization by the best academy. Now look at it. Alkenes are very good in addition reaction. Addition, you cannot add hydrogen to all these alkanes because the hydrogen is already in surplus. But you can add hydrogen to alkanes in the sense that after they have undergone the addition reaction, they will now be saturated. Their double bond will be broken. That's what I'm trying to say. So if you add hydrogen gas to this now, for example now, let's say 18, which is C2H4. If you add H2, which is hydrogen gas to it, it will be C2H6, which is now ethane. Which is now what? Ethane. That's what I'm trying to say. Then this one can also go into addition reaction. Alkenes can also go into addition reaction with all those what's it called? Halogens. Hydrogen halide, yes. Hydrogen halide. Not just anyhow halogen, but hydrogen halide. Now that will now bring us to symmetrical and unsymmetrical alkenes. Symmetrical and unsymmetrical alkenes. Now, if you want to add hydrogen halide to a symmetrical alkene, what is mean of symmetrical alkenes? Symmetrical alkene means when you look at the double bond, the number of carbon atoms here, or the number of what you have in the left hand side will be the same thing as what you have in the right hand side. That is symmetrical. But when what you have in the left hand side and what you have in the right hand side of the double bond, carbon carbon double bond that is there, they are not the same. It is unsymmetrical. If you want to add hydrogen halide to unsymmetrical carbon carbon double bond, what we use in most cases, especially those of them that will give us something that is not 50-50, sure. For example, now if you want to add let's say propene or prop-1 in, you want to add hydrogen halide. Hydrogen halide means hydrogen and halogen, like hydrochloric acid, fluoric acid, hydrogen bromide, and so on. That may be by hydrogen. That is hydrogen and halogen combined together. You want to add it to these alkenes now. If it is unsymmetrical, what you do, you use if it is unsymmetrical alkenes, you use the Markovnikov's rule. That's what you use. The Markovnikov's. You can read about that. Just read about symmetrical and unsymmetrical alkene and Markovnikov's rule. Although we'll do that later. Then we have alkynes. Alkynes and alkenes are somehow alike because they are both unsaturated, because they have multiple bonds. While alkenes is having double carbon carbon double bond, alkynes is having carbon carbon triple bond. That's what I'm trying to say. So remember, the alkenes can go to saturated compound, can go to hydrogenation, halogenation, and so on. Can go to addition reaction. Most of these unsaturated, this alkenes can also polymerize. It can also polymerize. But alkynes don't readily polymerize. But two molecules of ethyne at a particular temperature can polymerize somehow to form benzene in some cases, which is C2H2. That is, we just polymerize. You now put 3 at the back. We now have C6H6. We just something like polymerize to form maybe benzene, but that is not that common. So, but alkenes is very good in polymerization reaction to form basically polyalkenes like polyethynes. Polyethynes like polyvinyl chloride, polychloroethene like PVCs, and so on. So ethene is very good, like buta-1,2,1,3-diene, 3-methyl buta-1,3-diene, natural latex, rubber latex, and so on. They are from these alkenes. That's how the thing is. So this one can polymerize. Polymerization means the addition of a monomer to form a giant molecule that is called polymer. When you add monomers together, like you add a lot of ethenes together to now form poly, like so many ethenes, now call it polyethynes, and so on. Although we are not doing polymers now, I'm just trying to explain some things that you may like to know. Then that is just that. So now let's look at how to read this homologous series for alkanes. To look at what I'm going to do now. Alkynes, the simplest member of alkynes is the ethyne. The tribal name of this one is ethyl. Let's say acetylene. Acetylene. That's the tribal name of this, acetylene. Ethene can also be ethylene, as you know them, but the tribal name of these alkynes are the acetylenes. Although acetylenes is special for the for the molecule, that is for the compound ethyne. We have ethene, ethyne. Some people do call ethyne acetylene, or they just call the whole alkynes the acetylenes. This one, the tribal name is olefin. The tribal name is the paraffins. Take note of that. It's very, very, very important. That ethyne is sp hybridized. It has a carbon-carbon triple bond. It's sp hybridized, and it is linear or diagonal in shape with a bond angle of 180 degree. Take note that is very, very important. It's very, very what? Very, very important. So you can also check note of that. So what I want to do in this class now is to check how to something like name organic compound, or how to read the homologous series from number 1 to number 100. Shortcuts to do that. That's just what I want to show you quickly now. So let's go.
All right, now want to get the shortcut of listing out the homologous series of alkanes. Now, one thing is, if you can get this series of alkane, then you can get the series of alkenes and alkynes. The only difference between this one and that is just that the surface, there are surfaces. There are surfaces. Now for alkane, it ends with A-N-E, that's ane. Alkenes is E-N-E, in. Alkynes is Y-N-E, ines. That's just different. And for alkenes and alkynes, it starts from 2. There's no 1. So they start from 18 and ethyne and so on. So instead of it to be saying propane now, like this number 3 now, that is propane. So it to be saying propane, we just say propene for alkenes and propyne for alkynes. We already explained that. So now let's look at how to get all these names now at our figure tips. Now, you can actually name this compound from number. We are going to learn how to name them from number 1 to 100. That's what we are going to do now. From number 1 to 100. And we are not going to memorize everything. I'm going to give you a key that you are going to be using. In case they ask you what is number 77, you'll be able to name number 77 at just your fingertip. All you have to do is to follow the key I'll be dropping here now. So now, the first thing you are going to do for me, look at the keys you are going to. Now, there's also going to say the key to this. Now, the key to this, my method, as follows. We have like just few keys. You are going to something like a pick up, and you're already good to go. Now, key 1. Now, first key, you are going to ensure that you know from number 1 to 10. That's the first thing. You must know from number 1 to what? To 10. That one is simple. That is very simple now. Number 1 is methane. Number 2 is ethane. Number 3 is propane. Number 4 is butane. Number 5 is pentane. That end, all those end you are saying means normal. That is straight chain. It's just a straight chain. It's not a branch chain. It's just normal alkanes. That's what you are saying. Normal. Just straight chains. You have hexane. Number 6. Okay, number 5 is pentane. Number 6 is hexane. Number 7 is heptane. Number 8 is octane. Number 9 is nonane. Then number 10 is decane. Then we have you must know that number 1 to 9. Very important. Now I'm going to be using logic here. I'm going to be using logic. The logic I'm going to use, we are going to I will like you guys to know this logic here. Now the logic starts from you knowing from number 1 to what? Number 10. Very important. Very, very important. Then again, another logic. Note number 1, number 2, number 11, number 12. See, just note all these things down that I'm saying though, because this is what you need. Note number 1, number 2, number 11, number 12, number 21, number 22, number 31, number 32, 41 and 42, 51 and 52, 61 and 62, 71 and 72, 81 and 82, 91 and 92. Note those ones as well. Very important. Very, very important. All those, these 1 and 2, 11 and 12, then 21, 22, and even number 27 should be noted, because number 20 did not follow the trend that we are going to be using now. Also note number 20. So therefore you note number 1 to 10. That's the first thing. The secondly, you note number 11, 12, 20, 21, 22, 31, 32, then 41, 42, 51, 52, 61, 62, 71, 72, 81, 82, 91, 92, because all those 30, 40, 50, they're going to follow the same trend, but only 20 will leave the trend. I'm going to show you everything now, so note those things down. Very, very important. Now, take note of this. It's very, very important. As you are memorizing that number 1 to 10, take note of number 3. Number 3, we are going to be calling it from number 11 to 100. Anything 3, we'll be calling it try. Take note of that. Anything 4, we'll be calling it tetra. Take note of that. Anything 5, we'll be calling it pent or penta. Like all those shapes in mathematics: pentagon, hexagon, heptagon, octagon, and so on. Then anything 5, we call it penta. Anything 6, we'll be calling it hexa. Anything 7, we'll be calling it hepta. Anything 8, we'll be calling it opta. Then anything 9, we'll be calling it nona. Then take note of that. It's very, very important. So take note of 3, 4, 5, 6, 7, 8, 9, because the names will be repeat. It's not like just a repetition of what we have been doing in this number 5. Although 3 will now be 3 will not be prop again. 3 will be try. Then 4 will be tetra. Then we just be repeating them. All right, let's check now. Let's check. Number 1, maintain. Number 2, ethane. Number 3, propane. Number 4, butane. Number 5, pentane. Number 6, hexane. Number 7, heptane. Number 8, octane. Number 9, nonane. Number 10, decay. Number 11. Now check. Number 10 is decay. Then from 10 to 19, that decay will be showing up. It's just like we are adding. For example, now 11 means we add 1 to 10. It's just like 1 and 10. 12 means 2 and 10. It's just like an addition. This is just like an addition. Like 10 now, from 10 to 19, decay will be showing. 11 will be, look at how we do name it. 11 will be 1 plus 10. 1 here is on. Although the thing don't actually follow that very much. That I already told you, note 11, 12, 21, 22, 31. I already mentioned that, because those ones don't, for the trend don't actually follow. But from 3 to 9 follows very well. So 12 now will be like 2 plus 10. 13 will be like 3 plus 10. 3 and 10. Not even 3 plus 10, just 3 and 10. Then 14, 4 and 10. Okay, let's check. 11 is on decay. That is 1 and decay. On means 1. Then decay means 10. Then 12 means do decrease. Do means 2. Then decay means 10. Just like 2 and 10 join together form 12. Then 13 means try decay. That is 3 and 10. 3 plus, it's just like 3 plus 10, 13. Then 14 means tetra decay. That is 4 and decay, which is 10. 15, pentadecade. 16, hexadecade. 17, heptadecade. 18, octadecade. 19, nonadecade. Now let's check from 20 so that you see what I'm trying to say. Let's check from 20 so that you see what I'm trying to say. From 20 to, let's just do from 20 to 34 now. So you see what I'm trying to say here. Now let's check number 20. What's number 20 here? Now if you check, number 20 now is now bringing a new name, which is eicosane. Eicosane, just like eicosane. You can call it eicosane or eicosane. So when you know what you are saying. But that cosane should be there. Then, if you check that number 22, do still show there. It's just like that. Okay, thank God. This will follow now. Only 11 opt out. 12 also follow. Remember, 12 was 2 and 10, which is do and decay. Which is do decay. Now let's check this number. Check this number 22. Do and cosine. So 20 means, so 20 is just like 0 and not like just like 0 plus 20 cosine. So 20 is actually the cosine. That is the major thing. You should know that cosine, very important. So hen Eicosane means 21. Take note of that. That one is a very special name. That's a very special name. And is it going to follow for 31, 41, 51, and so on? That hen will be, that is what we will now be using for 1, not on again. And that's what I was telling you to something like note before. Then 2 follow. 2 and 20 means do and cosine. 3 and 20 means try and cosine. So note that number 20 is what? Cosine. But you don't just call it cosine. The 20 you call it eicosane. 21 will be hen eicosane. 22 will be do cosine. 23 will be tricosane. 24 4 and cosine. That is tetracosane. 20. Okay, if I say 27 now, what will you say? Heptacosane, which is 7 and 20. That's how we do name them. So from here now, let's just first tell you. 21 hen incosane, 22 docosane, 23 tricosane, 24 tetracosane, 25 pentacosane, 26 hexacosane, 27 heptacosane, 28 octacosane, 29 nonacosane. Now, let me ask you now. I don't know if you can get the trend now. The trend here, remember from 10 to 19, all of them were having decay. From 20 to 29 now, they're having what? Cosane. So if I ask you now, what is number 26? What's the name for number 26? What are you going to tell me? What is 6? 6 means what? Heza. What is 20? Cosane. Heza and cosane will give us what? Hexacosane. That is all. Check. Number 26 will be what? Hexacosane. That N you are seeing there means normal hexacosane. It's not an isomer of it. It's just a straight chain of hexacosane. Now let's check number 30 now. Let's check number 30 without wasting time. Number 30. Now, when we get to 30, 30 to 90, we follow that tetra. Thus from 30 will be tri, 40 will be tetra, 50 will be penta, 60 will be hexa, 70 will be hepta, then 80 will be octa, 90 will be nona. That's how it is going to be. But since we are not looking at 3, we are looking at 30. It will be tricotane, not cosane this time around. Tricontain, contain. So take note of that unique name. Contain is now the generic name now for all those 30, 40, 50, 60, 70, 80, 90. All of them will bury that contain. But the only thing that will differentiate them will be 30 will be tri, 40 will be tetra, 50 will be penta, and 60 will be what? Hexa, 70 will be hepta, 80 will be octa, 90 will be nona. Let's check and see. 30 is contain. Then 31, I already told you that one is unique, which is hen triacotane. 32 to 39 we follow do, tri, tetra. Just look at it. Number 31 means 1 and 30. Number 32 means 2 and 30, which is do, triacotane. Remember, 30 is what? Triacotane. Number 33 means 3 and 30, which is triacosane. Number 40 means 40 and 30, which is 4 and 30, which is what? Tetra-triacosane. 4 means tetra. 30 means what? Triacotane. Number 35 means what? Let's go to number 35. Number 35 is what? What will number 35 now? 5 and 30, which is pentatriacotane. The only name you just know the name, the number 30 name, which is triacotane, contain. Then 36 will be hexa-triacotane. 37 will be hepta-triacotane. 38 will be octa-triacotane. 39 will be nona-triacotane. Number 40 will be tetracotane. I already told you that. 40 will be tetra. 50. Okay, let's check now. 40 will be tetracotane. 50 will be pentacotane. 60 will be hexacotane. 70 will be heptacotane. 80 will be octacotane. Then 90 will be nonacotane. That is all. That's all. To me now, I've already gotten number 1 to 100. If you ask me the name of number 44 now, I will just tell you tetra and 40. 4 and 40. That will give us 44. Tetracotane. What's 44 there? Tetracontin. 4 and 40. That's how we do call it. To take note of that. It's very, very important. So if I ask you now, what is number 52? If I ask what is number 52, 50 is pentacontin. Then 52 will be 2 and 50, which is what? Dopentacontin. That is all. 52 is dopentacontin. Simple as ABCD. That's what you need to know. You need to understand the progression of this series. If you know the progression, if I ask you what is number 97, you just tell me 7 and 90. What is 90? Nona-contain. What is 7? Hepta. So 97 now will be what? Hepta nona-contain. You just go and check. If you go and check now, that's what you're going to see. Hepta nona-contain. That's all. This is number 97. We have 97 carbon atoms. So I don't know if you have gotten it now. Have you gotten the naming now for the list? So let's just name them. We have 41 tetra do tetracotin, tetracotin, penta tetracotin, heza tetracotin, hepta tetracotin, octa, nona. Then we go to 50, which is pentacontin. Then 51 pentacotin, 52 do-pentacotin, 53 tripentacotin, 54 tetra, 55 penta, 56 heza, then 57 hepta, octa, nona, 60 hexacontin, then 61 hexacontin, then 62 do hexacontin. It's just repetition of what we have been calling on, do, hence. The one they are now using now is hence, do, tri, tetra, penta, heza, hepta, octa, nona, and that is all. Then they'll go back again. Do. That is all. That is all. Just check. Just check. Just check. 60 now. 60 is hexacontin. 61 is heza. That is 1 and 60. Then 62 is 2 and 60. 63 is 3 and 60. 64 is 4. 4 is tetra and 60, which is hexacontin. 65 is what? 5 and 60, which is pentahexacontin. Then 66 is 6 and 60, hexacontin. 67 is 7 and 60, heptahexacontin. Then 68 is 8 and 60, octahexacontin. 69 is 9 and 60, nona-hexacontin. 70 is what? Heptacontin. I already told you 30, 40, 50, 60, 70, 80, 90. Follow tri, then tetra, penta. The only thing is that you just put pentacontin, hexacontin. All those ones are just tetra, and triacontin is 30. Tetracontin is 40. Pentacontin is 50. Hexacontin is 60. Heptacontin is 70. Then octacontin is what? 80. Nona-contin is what? 90. If you know those ones now, if I now ask you what is number 71, what is number 71? Just call 1 and 70. That is all. Which is hence heptacontin. What is number 72? Do heptacontin. Number 73, tri heptacontin. Number 74, tetra heptacontin. Penta, heza, hepta. Then nona, you go back to the next one, which is 80, octacontin. Then you go to number 1, 80 and 1, which is hence. Then 80 and 2, do. 80 and 3, tria, tetra, penta, heza, hepta, octa, nona. Go back to 90 again. 90 is what? Nona-contin. Then 91 hence nona-contin. 92 do nona-contin. Number 93 is tria nona-contin. Number 94 is tetra nona-contin. 95 is what? Penta nona-contin. 96 is what? What is 96? Heza nona-contin. 97 is what? Hepta nona-contin. 98 is what? Octa nona-contin. 99 is what? Nona-contin. Don't be something like the thing is funny. It is how it is. It is what it is. It is what it is. That's how the thing is moving. So that's how it is. Then note number 100. Hectane. Hectane. Note that number 100 because that is unique. Because 100 is now a new number again now. So I now have it like three digits and now 100. not 2 digits again. So that's why that one is carrying a new name. So from this our movement now, we can even predict number 101, 102. From this our movement, we have been moving 6. But there's no need of that. So let's just quickly run our method to see if we are actually following. So we repeat again. Number 10 is decaying. Number 20 is what? Equals saying. Remember, 20 is saying. Decaying. And 10 is cane. Decaying. That is decaying, not decaying. Then 20 is equals saying. So 10 is cane, 20 is saying. Then from 30 to 90 is contain. So 30 is triacontain, 40 is tetracontain, 50 is pentacontain, then 60 is hexacontain, 70 is what? Heptacontain, 80 is octacontain, 90 is what? Nonacontain, then 100 is what? Hectane. Now, if you know that number, you should know that is at maybe by now. Because at this point now, as a student that is following this class, you should know number 10, 20, 30, 40, 50, 60, 70, 80, 90, 100 now. Those are the major things now we now need. So what is now number 55? If I ask you now, what is number 55? What are you going to tell me the answer is? Number 55 is not different from 50 and 5. It's just like 5, you call the 5 first, what 50? 5 and 50. What is 5? Penta. What is 50? Pentacontain. So 55 will now be pentacontain. Let's check if we are correct. Go to 55 to see it. Check 55. You can see pentacontain. Simple as ABCD. Now let's look at another one. Let's test run another one. Let's just do little test run. Now, what is number 20? L-cosine. Remember, 20 is cosine. That's 20. Now, what is now number 27? That is 7 and 20. Now, what is number 7? Heptane. Remember, hepta is number 7. Hepta. Then, what is 20? Cosine. So 27 will now be heptacosane. Let's check if you are correct. 27, heptacosane. Can you see it? Heptacosane. So you just note the generic name. Just know the name. That is the leader of that group. The leader of 20 is cosine. The leader of 30 is triacontain. The leader of 30 is 40 is tetracontain, and so on. If I ask you now, what is number 45? 5 is penta, then 40 is tetracontain. So 45 will now be penta tetracontain. It's just like call 5, call 40, that is all. So let's check number 45 to see it. So check number 45, penta tetracontain. Simple as ABCD. As at now, I'm going to stop this class here. Try your best to understand what we are doing here. In case you don't get it, just put it in our comment section. Then maybe I'll have to review the class over and over again so that you don't remain here. So that is number 1 to 100 for you. Thank you.